When we look up at the night sky, we see only tiny sparks scattered in the darkness, but beyond those faint lights lies a vast cosmic ocean. In that endless expanse, two small spacecraft launched in the 1970s have traveled farther than anything humans have ever sent into space. These travelers are Voyager 1 and Voyager 2, NASA's oldest and most distant explorers. They were created when technology was simple compared to today. Yet these aging machines have outlasted supercomputers, space shuttles, and even generations of engineers. Their mission was originally planned to last 5 years, but decade after decade, they continued sending whispers from the unknown, and those whispers reshaped how humanity sees the universe. The story of the Voyagers began in 1977 at Cape Canaveral. Standing tall on the launch pad, each spacecraft waited for its moment in a rare cosmic alignment. This planetary alignment, which happens only once every 176 years, created a perfect gravitational highway through the outer solar system. Scientists realized they could use the gravity of giant planets like Jupiter and Saturn to slingshot the spacecraft farther and faster than any rocket alone could manage. But they had one chance, one window in history to do it. Missing that window meant waiting almost 2 centuries. Voyager to launch first on August 20, 1977. Voyager 1 followed on September 5th. Despite its later launch, Voyager 1 took a faster route and quickly overtook its sibling. The risks were immense. The spacecraft had to survive freezing temperatures, deadly radiation belts, and micrometeoroids traveling faster than bullets. One tiny shard of metal or rock could have ended the mission instantly. But NASA engineers had built the Voyagers with layers of protection and redundancy, trusting that these machines could endure the unimaginable. Each spacecraft also carried a message, the Golden Record. Carl Sagan and his team curated greetings in dozens of languages, sounds from nature, pictures of Earth, scientific diagrams, and music from many cultures. They included the sound of a heartbeat, a mother kissing her child, and the rhythm of waves hitting the shore. They added images of mountains, deserts, forests, and cities. They even placed encoded mathematical descriptions of hydrogen and DNA, hoping that any advanced civilization could understand them. The Golden Record was humanity's letter to the universe, a quiet hope that if someone ever found these machines wandering among the stars, they would know we once existed. Voyager 1 reached Jupiter first in 1979. As it approached, Earth waited in anticipation. The first images sent back were breathtaking. Jupiter's swirling cloud bands came alive in color and motion. The Great Red Spot, a storm bigger than our entire planet, revealed layers of violent winds spinning for centuries. Voyager detected lightning bolts that lit up the planet's atmosphere with incredible energy. It also discovered something unexpected. Jupiter had thin, faint rings, something scientists didn't know existed. Then there were the moons. Io shocked scientists with its massive volcanic eruptions. No one expected a moon so far from the sun to be the most volcanically active place in the solar system. Europa revealed long cracks on its icy surface, suggesting a global ocean beneath. Scientists realized that Europa could be one of the most promising places for alien life. Ganymede, the largest moon in the solar system, had its own magnetic field. Callisto showed signs of ancient impacts and possibly subsurface oceans. The Jovian system was far more alive and complex than anyone imagined. Every new image, every piece of data, revealed a solar system full of surprises, constantly challenging humanity's understanding of the cosmos. Voyager 2 continued behind the sibling and reached Saturn in 1981. Saturn's rings looked like delicate cosmic artwork, made of countless particles from tiny dust grains to massive chunks of ice. The Voyagers photographed ring divisions, waves, and braided structures that looked almost unreal. They found new moons, some shepherding ring particles like cosmic guardians. Titan, Saturn's largest moon, had an atmosphere thicker than Earth's. It was full of organic molecules, raising new questions about what might lie beneath its orange haze. Scientists imagined landscapes of icy plains and lakes of methane, worlds completely unlike anything on Earth, yet eerily alive in their own way. Voyager 1 completed its planetary tour at Saturn and then angled upward, heading out of the solar system. Voyager 2 continued deeper, visiting Uranus in 1986. Uranus was strange. Its axis was tilted almost 98 degrees, making it spin like a rolling ball. The spacecraft discovered dark rings, active weather systems, and moons with unusual features. Miranda, for example, had cliffs taller than Mount Everest and surface patterns that looked like mismatched puzzle pieces. Uranus revealed that planets are not always perfect spheres, that each world carries its own secrets, and that the solar system is full of surprises waiting for those who dare to explore. Then Voyager 2 pushed even farther to Neptune in 1989. It discovered the Great Dark Spot, a massive storm nearly the size of Earth. The winds on Neptune blew at over 1,000 miles per hour, faster than any wind recorded on Earth. Triton, Neptune's moon, left scientists speechless. It had nitrogen geysers shooting miles into the air and a surface that hinted at underground activity. Triton orbited backward, suggesting it was once a wandering object captured by Neptune's gravity. These distant worlds, once invisible and abstract, became real, tangible places with their own storms, landscapes, and mysteries. After leaving the planets, the Voyagers entered a region where the sun's power begins to fade. This area, filled with charged particles from the sun, is the heliosphere, the bubble that shields our solar system from cosmic radiation. The Voyagers continued gathering data, measuring how the solar wind changed as they moved farther away. In 2004, Voyager 1 entered the termination shock, where the solar wind suddenly slowed and became turbulent. This was the first step toward leaving the solar system entirely. Voyager 2 crossed this boundary in 2007, revealing that the solar bubble wasn't perfectly shaped. It was compressed and stretched by magnetic forces from the galaxy. The very edge of the solar system was more complex than anyone could have imagined. The next border was the heliopause, the true edge of the solar system. Voyager 1 reached it on August 25, 2012. Scientists knew it had crossed the boundary when it detected a dramatic drop in particles from the sun and a surge in galactic particles. For the first time, a human-made object had entered interstellar space. It was a historic moment. Voyager 2 crossed the same boundary in November 2018, confirming what Voyager 1 had detected years before. The data they collected transformed how scientists understood the sun's interaction with the galaxy. They revealed that our solar system is not isolated. It is part of a vast, dynamic cosmic environment filled with forces we are only beginning to understand. Inside interstellar space, everything became even more mysterious. The Voyagers detected dense plasma, leftover debris from ancient stars that exploded long before Earth even existed. They recorded vibrations caused by distant solar storms that traveled all the way from the sun to the edge of the solar system. These vibrations created haunting, almost musical tones, which some have called the song of the galaxy. The Voyagers measured cosmic rays coming from supernova explosions millions of years ago. They mapped magnetic fields in interstellar space, showing that the environment outside our solar system is far from empty. It is a swirling ocean of particles, fields, and energies. Each discovery added a new layer of understanding, revealing a universe alive with motion, power, and history. Today, the Voyagers continue their slow journey. Their power sources weaken each year. Engineers shut down instruments one at a time, trying to keep the spacecraft alive as long as possible. These engineers work with computers and technology older than their parents. Some of the people who helped build the Voyagers have passed away, yet their creation still speaks across billions of miles. It takes more than 20 hours for a signal to reach a Voyager, and another 20 hours for a response to return. And still, the Voyagers continue sending faint whispers home, proving that even the oldest, simplest machines can still make history. One of the most emotional moments of the entire mission happened in 1990 when Voyager 1, at Carl Sagan's request, turned around and photographed Earth from nearly 4 billion miles away. The result was a tiny pale blue dot suspended in a ray of sunlight. That photograph captured the fragility of our world, the fact that every life, every nation, every joy, and every conflict exists on a mote of dust floating in a vast cosmic darkness. Sagan later wrote that everyone we love, everyone we know, everyone who ever lived out their lives on that small dot. The image reminded humanity that we are all connected, all temporary, and all part of something far bigger than ourselves. As the Voyagers drift farther into the galaxy, sunlight becomes a distant memory. They travel through regions no spacecraft has ever entered. In 40,000 years, Voyager 1 will pass near another star. Voyager 2 will follow hundreds of thousands of years later. These machines will outlive every civilization on Earth. They will drift through the Milky Way long after humans have changed, evolved, or vanished, and yet, they carry with them the story of our species, encoded in golden disks and transmitted through faint radio waves. Eventually, their power will fade completely, their instruments will fall silent. But even then, the Voyagers will continue on their endless journey, and each one carries the golden record, the sound of rain, the laughter of children, the music of our world. If another civilization ever finds a Voyager, they will learn that long ago, humans reached out into the stars with curiosity, courage, and hope. The Voyagers are more than machines. They are symbols of the human spirit, reminders that even small creations can achieve impossible journeys. They show that, when humanity chooses to look beyond fear and uncertainty, we can reach farther than we ever imagined. They remind us that exploration is not just about technology, but about curiosity, imagination, and the desire to understand our place in the universe. And as these two explorers drift through eternal darkness, they carry with them a quiet message from Earth, that we lived, we dreamed, and we dared to explore the unknown. If you enjoyed this journey and want more stories like this, make sure to subscribe to the channel and join us as we continue exploring the wonders of the universe, uncovering the secrets of distant worlds, and following the paths of humanity's greatest explorers.